In this video, we're going to talk about slope. We're going to talk about what is slope, and we're going to find slope on a graph. So what is slope? Slope is a rate of change, and a rate of change is a ratio that shows how one variable changes with respect to another. So rate of change might be how fast somebody's going over time, or rate of change might be how many roses someone sells per hour. That's a rate of change. How fast are things changing? That's what a rate of change is. On a linear graph, this is called the slope of a line, and the rate of change is consistent the whole time. Things are changing at the same rate the entire time. So what is slope? Continued. Slope is written as the ratio, remember ratio should signal in your brain fractions, of the vertical change, which is the rise, to the horizontal change between any 2 points on a line. How things are changing vertically over how things are changing horizontally between any 2 points on a line. We'll talk more about this. I'll show you what it means here in just a second. This remains constant for any 2 points on the same line. No matter what 2 points you pick, you are going to get the same slope if it is linear. Slope is always written as a fraction in simplest form, and the variable for slope is m. I like to say it's how you move from one point to the other. That's why it's m. There are different types of slope. A positive slope, as you move horizontal, as x increases horizontally, vertically y increases. So that's a positive slope. This is a negative slope. This is a zero slope, and this is an undefined. Watch a couple videos here to really drive home positive, negative, zero, and undefined.
This is a toy that my son loves to play with, and because I'm a math teacher, I instantly saw its application to algebra. If you get the slopes of the ramps just right, it will drop into the basket below. If you look at the ramp below, I'm going to make it more steep. What do you think is going to happen now when the gear goes down? If you said it's going to have too much momentum and it's going to fly out, you are right. If I make it really steep, it might drop in, or it might fly out. It would be nice to compare the slopes of these two ramps. Obviously, this one is not as steep as the bottom one, so its slope is less. However, let's see how much less. So I plotted 2 points at the corner of the grid markings, and I'm drawing a line. And I'm going to label that A, and then I'm going to do the same thing for the bottom ramp there. And we're going to compare their slopes and see how much more steep B is than A. So I'm going to use a triangle to figure out what the rise and run is from one point to the other point. So I went straight over 1, 2, 3, 4, 5, and then straight up 1, using the grid to draw my triangle. And rise over run is 1 over 5. This is a positive slope because it's going up from left to right, so I'm going to leave it positive 1/5. B is a negative slope because it's going down from left to right, and its slope is 1 over 1. So I'm going to put the negative on the top one, but you can put it on the bottom one, just don't put it on both. Negative 1 divided by 1 is negative 1. So 1/5, we already know that slope A is less than slope B, but we need to compare the absolute values of those slopes. So there we go. 1/5 is less than 1. It's a lot less than 1. So the slope of A is a lot less than the slope of B. Now let's look at a horizontal line and what slope it has. So if I try to move the gear and just tap it like I did before, it just moves a little bit. I thought it wasn't going to stop, but it does. You couldn't ski on a horizontal line. It's impossible. So this is a slope of 0. You aren't going anywhere on a horizontal slope. So that's a 0, but you'd still be able to stay on that slope. If I change it to a vertical line and I try to put the gear on there, It's not going to roll, it's just going to go straight down and drop. You couldn't ski on a slope like this. You would just fall and break your neck. This is the undefined slope. It's an impossible slope.
Now that we've watched a couple of videos on positive, negative, zero, and undefined, let's take a look at how you find the specific slope on a graph. All right, so we said in the beginning that slope is the vertical change over the horizontal change. In other words, the rise over run. And the directions say find the slope of each line. So we need to know how steep is this line and to write our answer in simplest form. So there are already 2 points marked here, and we'll talk a little bit about how to pick good points, but we're just going to pick those 2 points. They're already marked, and we're going to find the run first. So we're going to go and we're going to count the blocks 1, 2, 3, 4 until we're directly underneath this dot here. So the run is 4, and that goes on the bottom. Just pretend you're telling directions, like here's your house and here's Billy Bob's house, and your name is Ashley, and you need to know how to get from Ashley's house to Billy Bob's house, and these are streets. Well, you're going to tell Ashley, you're going to go from Ashley's house to Billy Bob's house. You're going to go 1, 2, 3, 4 blocks over, and then you're going to go 1, 2, 3, 4, 5, 6, 7 blocks up to Billy Bob's house. That's my rise, that's my vertical change, so I'm going up 7 over 4. So M equals 7 over 4. That's my answer, and it's simplified. That's as simple as it gets. Let's do another one. So we're going from this point to this point, and it's really helpful to go to the one that is the furthest to the left, and then go to the start on this one, and then end on the one that's the furthest to the right. But it doesn't really matter. You should get the same answer no matter what. So I'm going to run over, always run first. So 1, that's 1 block. Don't count this as 1. This is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think I need to count that again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So my run is 9. That's the number that goes on the bottom. Slope is easy and fun. Just remember, rise over run. And then my rise is 1, again, 0, 1, 2, 3. Now, remember, this is a negative slope. I went down, which is a negative direction. So this fraction is going to have a negative on it. It's going to have 1 negative. You can put it on the top number since that was your rise. You can put it on the bottom number. You can put it on the fraction bar, but only put it in one place. Now, you might be screaming at the screen, this can be simplified! And if so, gold star for you, you are correct. I can simplify this because both of these numbers are divisible by 3. So the simplified slope is negative 1/3. Now let me show you what that means. What that means, let me change colors here real quick. What that means is that there is another point where if I run 3, 1, 2, 3, down 1, I'm on the line. 1, 2, 3, down 1, I'm on the line. 1, 2, 3, 1, I'm on the line. So that just means there was a closer point that I could find to do my slope than using those two. Now you remember I said, if they give you points, use the points they give you, but sometimes you're looking at a graph and there's no visible points on there. There's no points marked. So what do? Well, you got to find marks that are going to allow you to count full blocks. Sometimes the y-intercept, where it intercepts the y-axis, is a good one, but not always. In this case, that's a good one, so I'm going to use it. Now, as I'm going along the line, technically I could put a point anywhere on these lines. These are all points. They're not marked, but any spot on the line is another point. But those aren't all good ones to use. Now, why are they not all good ones to use? So this one is a good one to use, but if I use this one, then when I count these blocks, I'm counting like, is that a half a block? Is that a third of a block? Is that a fifth of a block? I don't know. So I want to try to use intersections on my grid so that I'm counting full blocks. So as you're going along the line, you want to stop at a cross section at an intersection. So there would be another good point to use. There would be another good point to use. Okay, but don't use this because it's not at a crosshair, so you wouldn't be counting a full block. Hopefully that makes sense. Okay, so I'm going to use those two. And remember on the last one, if you pick this one and this one, I'm going to get the same answer, but I'm going to have to simplify it because it's not the closest two together. So on this one, I'm going to do rise over run. So I'm going to always run first. So I'm running, and I stop when I'm right underneath that dot, and then I go up to that dot. Now, how far did I run? Now, this is tricky. Look at your x-axis. Each block here is not 1, it's 10. So I actually ran 10 blocks, 20 blocks, 30 blocks here. And then here, from here to here, I ran from 40 to 50, which is 10 blocks, So my rise over run, I'm rising like the sun. Running is this way, left and right. And I can still simplify that. Now I said you could, if you pick the two closest to each other, you wouldn't have to simplify. But I did because I'm going by tens. If I were to zoom in on this, there would be a closer point. You just can't see it. So this simplifies, the zeros cancel out, and my slope is 1/3. Now, if you counted 1, 2, 3 blocks, and I counted 1 block, it actually works out okay to not go by tens on this one, but that's just because my y and x-axis have the same units. That's not always going to be the case, so be careful of that. So now, hopefully, you now know what slope is. It's a measurement of how steep the line is and how fast things are changing, the rate of change is going. And then hopefully you now know how to find slope on a graph.